Okay, tangent. Tangent's different to sine and cos. Let's talk about a normal Cartesian plane and me doing the line y equals x. What's that angle? That angle is 45 degrees because the line y equals x, for every one I go out, I go up one. I go out one and up one. Or I go out two and up two. So I'm going to draw some lines here. My blue line is 1. My red line is 1. So the slope is rise over run, which is 1 over 1, which is 1, rise over run. Easy, yeah, the slope is 1. We know that. So I'm going to cover that. I'm going to come back to this line and I'm going to rub out the line y equals x, and I'm going to draw that in a bit smaller. We know that that's 45 degrees. If this was just a triangle without any of that, we would go tan is O on A. Well, O is this thing here, and A is that thing there, which are also called different things. So, what we can change down here is rise is actually O and run is actually A. So the slope of the line y equals mx plus c, so that's m, is actually the same as tan theta, where theta is the angle between the x-axis and the line. So whether it's a line or a terminal ray doesn't really matter. The tangent ratio and the slope of a line have a very, very close relationship. They are the same thing. So what we can say is if the slope of a line is positive, then tan has to be positive because they're the same thing. What if the slope is negative? That would mean that tan is negative. So tan is the same as the slope of the line. Yay. That means it's easy. Tan 130. Let's not do 130 because I don't like that. How about tan 120? Where's 120? 120 is here. So I need to get the value. So I need my reference angle. So that's 60. My reference angle is 60. So I need to draw a 2, 1, root 3. Tan is O on A, which is root 3 on 1. So there we go. We know the value of tan 120 is root 3. We know the value is root 3 because that triangle and that triangle are the same triangle. So the ratios of the side lengths are the same. More specifically, let's go blue, and red that red is going to be root, oh my gosh, root 3, and the blue is going to be 1 because I've drawn my terminal ray with a length of 2. Anyway, that's where the root 3 comes from. All we really need to say to work out whether or not this thing's positive or negative is to go, what's the slope of that line? What's the slope of that line? Tan is the slope of the line. Slope is negative, therefore tan is negative in quadrant 2. Therefore, tan 120 is negative root 3. I jumped off that pretty quick, but there you go. Five pi on 4. Well, guess what? That is 1/4 of pi, 2/4 of pi, 3 pi on 4, 4 pi on 4, 5 pi on 4. There's my terminal ray. That's 5 pi on 4. And come on. I need to get my reference angle, which is pi on 4. So I need to draw my acute triangle. 1 root 2, because that's pi on 4. We are quite within our rights to go, therefore, because tan is O on A, tan 5 pi on 4 will be O on A, which is 1. And, okay, tan is the slope of the line, slope positive, therefore tan is positive in quadrant 3, so our answer there is just positive 1, so we don't really need to change anything. So what's tan 5 pi on 4? Positive 1.